Okay, so now we'll move on to the next part of our lesson, integrating expressions by using the method of completing the square. So what do you mean by, why do we need to use completing the square? Now look at the type of integrals that we are going to deal in the next exercise. In the next exercise, can you see the type of integrals we have? We have 1 over, now earlier we had just x square minus a square, x square plus a square, right? So there are only 2 terms in the denominator, but now we have a full trinomial quadratic expression. Can you see? There's x square, there's x term, and there's a normal number. So you have the full trinomial expression in the denominators. Then does it immediately fit into our format that we learned? It doesn't, right? So because of that, they you have it in this form and with the root form anyway. None of them immediately fit into the format that we learned. Okay, so then what we are going to do is we are going to use the results that we derived previous. Now these are the rules that we have, right? We have root a square minus x square, a square plus x square, which is have 2 terms. So basically what we are going to do is we are going to convert this trinomial quadratic expression into this type. We are going to convert it. Okay, so we are going to convert it and we are going to apply all the rules that we learned earlier. However, I think you can see now they have given you 2 more extra rules here. Do you see? I think earlier we stopped at rule number 15 in the previous exercise. Am I correct? Yeah, we stopped at rule 15. So now they have introduced you 2 new equations. The integration of 1 over a square minus x square is 1 over 2a times ln a plus x over a minus x. And the 17th rule is integration of 1 over x square minus a square. So now make a note of these 2 rules as well. And they, as you can see with the asterisk mark, it mentions that these rules are available in your formula book as well. Okay, so make a note of it in your writing book because you need to add these into your set of rules. So you can see now the rules have extended how many? 17 rules. So now we are working with 17 rules of integration in this lesson. Okay, make a note of it. Okay, so now to do a question of this pattern, what we do is, now you know that we have these rules that we derived earlier, right? So to work with these rules, you know, we can't have a trinomial expression in our denominator. So what I want to do is, you must use completing squares here. So let's use completing square. Take the quadratic equation separately out here and let's complete the square. What do we have here? When I rearrange, I'll rearrange and write it's minus x square minus 4x plus 5, right? Can you all complete the square for this? So P1, in completing the square, you know, x square coefficient must be 1, right? We can't have 2x square, 3x square, minus 1x square, no. So take the minus 1 out first. So when I take minus 1 out, what's remaining? I get positive x square plus 4x. Close the big bracket. Outside you have 5. I prefer to keep the plus 5 out of my completing squares. Okay. Then minus 1 stays out. Inside the curly bracket, let's complete the square. Open bracket, instead of x square, we write x plus half the value of 4 is 2. Close bracket square. Compulsory minus 4. Right? And then close the curly bracket and we have plus 5. So minus 1 multiplies in. So we have minus x plus 2 square. Minus into minus is plus 4 plus 5. Do you agree with my working? Minus x plus 2 square plus 9. Or in other words, 9 minus x plus 2 square. So this is the completing square part. Do you agree with me? Yeah. So when I write the sum, 1 over root 5 minus 4x minus x square. What do we work with here? Instead of writing 5 minus 4x minus x square, we can write the completed square format. What is it? 1 over root 9 minus x plus 2 square. Are you with me? We come to this form. Now what you need to do is, we are going to use a substitution. So I'm going to say let's say u be equal to what? The part that I need to have a single value here, a single variable here, right? So look, let's say let u be x plus 2. U is x plus 2. So which means what? Du by dx is equal to 1. Because when you differentiate x, you get 1, right? Which means du is equal to dx. Are you with me? So when I input these values, what do I get? 1 over root 9 minus x plus 2 square is what? U square. plus 2 is u, x plus 2 square is u square. Dx becomes du. Okay, so now look, 1 over root 9 minus u square. Doesn't it look like one of the rules that we have over here? So it looks like which rule? 9 minus, so a square minus x square. Rule number 12, right? A square minus x square, the u is in place of x here. A square minus x square is rule number 12. So here your a value is 3. So let's use the rule. A square minus x square is arc sine x over 3. U over 3. Yes, it shouldn't be x, it should be u. Arc sine u over 3 plus c. However, you are not done because the u was a substitution. So you must replace the u back with the original. Who is u? U is x plus 2. So our final answer will be arc sine x plus 2 over 3 plus c. So it's quite easy. Even though you have a trinomial expression, we complete the square and we make it into 2 sections, and then this part with the square, the x part, you need to replace it with a simple letter, and then your answer comes quite easily by using these rules again. Do you understand? Okay, shall we try the next one? Okay, so let's move on to part C. 1 over root x square plus 6x plus 10. So again, the same story. Okay, so we will complete the square for x square plus 6x plus 10. When I complete the square, this one there's no problem. I don't need to take anyone out, so I can directly complete the square. X plus half the value of 6 is 3 square minus square of 3 is 9. This is completing the square for x square plus 6x. And there's a plus 10. So basically I get x plus 3 square plus 1, right? Do you agree with me? So when I move on to the question, one over root x square plus 6x plus 10. So this we can replace the x square plus 6x plus 10 with the answer we found the completed square format. Let's input that. So we get integration 1 over root x plus 3 square plus 1. Okay. Then what do we do? Now, next thing we do is we substitute, right? Let x plus 3 be equal to u, which means we get dx equals du, because du by dx equal 1, dx equal du. Let's input that into our equation. So integration 1 over root x plus 3 becomes u. So u square plus 1 dx is du. So 1 over u square plus 1. 1 over u square plus 1 is, so I have here u square plus 1 falls to the 14th root u square plus 1 falls to the 14th rule, isn't it? So this one, it gives me r shine u over 1 plus c. Then we get here r shine u is x plus 3. So basically r shine x plus 3. Is that okay? Then let's try the next one, part H. Try the next one, part H. So first we need to work on with 9x square minus 8x plus 1. We have to complete the square, right? So can I complete the square with the 9 here? No, we'll take the 9 out. So big bracket, x square minus 8 over 9x, right? So we take 9 out from both of them. Now complete the square inside the big bracket. X minus half of 8 over 9 is 4 over 9. Square minus, we get 16 over 81. And outside the bracket, I have a plus 1. Okay, so input the 9 again. So 9 times x minus 4 over 9 square minus 16 over 81 times 9. 9 multiplies with 16 over 81 to give you 16 over 9 plus 1. Add the minus 16 over 9 plus 1. Minus 16 over 9 plus 9 over 9 is minus 7 over 9. Is that okay? Right. Now let's go for the integration part H. So in part H, we have integration of 1 over root 9x square minus 8x plus 1, right? So when I integrate, what do I get? Before integrating, let's substitute. We get 9 times x minus 4 over 9 square minus 7 over 9. Is okay? And now, let's substitute. What's the substitution? Let u be equal to x minus 4 over 9. Is that okay? And then when we differentiate, we get du equal dx, same as earlier. So then let's input the values here. 1 over root 9 times x minus 4 over 9 is u. So it becomes u square minus 7 over 9. Dx becomes du. Do you agree with me? Du equal dx here. Okay. And then now can I use any of these rules? You can't take the, you can't do any of these rules while the 9 is there. So you have to take it out. So when you take the 9 out, u square minus 7 over 9, when you take a 9 out, it becomes 7 over 81, right? Because you divide by 9. Now the 9 comes out of the root, the common 9, it comes as a 3. So basically it's in the denominator, so 1 over 3. Integration of 1 over u square minus 7 over 81 root. So which rule does this fall under? U square minus, it falls for u square minus 7 over 81 root. X square minus a square root. So x square minus a square root is rule number 15. Rule number 15. So r cos x over a. By the way, what's our a value? So a square is 7 over 81. Are you with me? Which means a is the root of this. It becomes root 7 over 9. So what is the answer here? 1 over 3 r cos x over a, right? R cos x over a. So 1 over 3 r cos x over a is root 7 over 9. The 9 goes up. 1 over 3 r cos 9x over root 7 plus c. Is that okay? Minus. Yeah, so this should not be x, this should be u because we're doing this with u, right? This should be u. And then we should replace our u with x minus 4 over 9. Let's replace 9 over root 7 times u is, what was u? X minus 4 over 9, right? So 1 over 3 r cos 9x over root 7 minus 4 over root 7, right? Do you see? Okay. Yeah, so I think I can make it a little bit better by writing it under a common 9x minus 4 over root 7 plus c. Is this okay? Question number 5. So they're asking you to show that the integration from 1 to 3 for 1 over root 3x square minus 6x plus 7 with respect to x is 1 over root 3 ln 2 plus root 3. We have to show this. Okay, before we even think of it, we show that first thing is what? We can't deal with the trinomial expression. We need to complete the square. So take it out first. 3x square minus 6x plus 7. How do we complete the square? First take the 3 out. So when you take 3 out, I get x square minus, not minus 2x, because we divide by 3, right? Now we can complete the square. So x minus half of 2 is 1, square compulsory minus square of 1 is 1, and outside there's 1. Is it okay? 3 times x minus 1 square minus 3 plus 7. I end up getting 3 times x minus 1 square minus 3 plus 7 is plus 4. Do you agree with me? And then let's input that into this equation. 1 over root 3x square minus 6x plus 7 from 1 to 3. So this becomes 1 over root 3 times x minus 1 square plus 4 dx. Integrating from 1 to 3. Are you with me? Now it's time to substitute. Let u be equal to x minus 1, which means du becomes dx. Okay, so shall I write it in the corner here? Let u be equal to x minus 1, which means du equal dx. And also remember, now we are input changing your the variable, right? X becomes u, which means what? You know, we are dealing with limits here. Your limits also must change. Your u limits, you can change it to x limits can be changed. You must change it to u limits. So x limits are 1 and 3. So when x is 1, what is u? U is x minus 1, right? So when you input x as 1, 1 minus 1 is 0. And when x is 3, 3 minus 1, it becomes 2. Okay, so these are the u limits. Let's input them. 1 to 3, 1 becomes 0, 3 becomes 2. Are you with me? I input the new limit. So root 3 times u square plus 4. Now take 3 out. Yeah, shall I directly take root 3 out? Can you all manage that? Or else let me do it inside. 3 times u square plus 4 over 3. This is now du, right? Dx becomes du. I changed it to u limits. Okay, it should be du, right? So taking the 1 over root 3 out, integration of 1 over root u square plus 4 over 3 du. Okay, so what is the rule number? U square root x square plus a square. Root x square plus a square is r shine x over a. Okay, rule number 14. R shine x over a. So a value is a square is 4 over 3, which means a is 2 over root 3 square, rooting both the sides. 1 over root 3, it's r shine x over a. X is in here, u over a is 2 over root 3. Do you agree with me? And this time we need to put the plus c because there are actual integration limits. So I get here 1 over root 3. R shine, the root 3 can come up, right? Root 3. Our limits are from 1 to 3. Limits are from 0 to 2. I'm sorry. Yeah. I have input the x limits. The u limits are 0 to 2, right? Okay, let's input the values. 1 over root 3. R shine root 3 into 2 over 2 is r shine root 3. Minus 1 over root 3. R shine 0. Okay, so I think we need to get a show that here, right? 1 over 3 ln 2 plus root 3. Okay. So r shine root 3, we have r shine x, the formula, the r shine x equation which we learned in lesson 1. What is r shine x? Ln x plus root 1 plus x square, right? Ln x plus root 1 plus x square is 3. Is that correct? Ln x plus root 1 plus x square. This is r shine x. R shine 0, I think is 0, right? Isn't it? R shine 0, you can type in the curl and see, or else if you use the ln equation, ln 0 plus root 1 plus 0. So it's ln1 becomes 0. 1 over root 3. ln 4 is root 4 is 2. 2 plus root 3. This guy becomes totally 0. ln1 becomes totally 0. So is this show that 1 over root 3 ln2 plus root 3? Yes. Okay, so this is show that.